Good morning class. The topic which we are going to study today is the rank method, also known as Spearman's rank difference method. So when the variable under consideration are not capable of quantitative methods, then we deal with which characteristics? We deal with the qualitative characteristics and we use rank method. The formula used here is RR is equal to 1 minus 6 summation D square divided by N square minus 1, where RR is known as rank correlation. Technically Greek letter rho is also used for it. Summation D square is equal to square of the difference of difference of rank of each pair of observations, and N is equal to number of pairs. Spearman rank difference coefficient of correlation range between the limit -1 to +1, and in our class we are going to discuss the three cases. There are three cases. The first case is when the ranks of items are given in the questions. The second case is when the ranks are not given, and the third case is when some values or ranks are equal. That is the case of timed ranks, equal or repeated ranks. Now we will proceed with the numerical part. Case 1, when the ranks are given. The question here is use rank correlation coefficient to determine which pair of judges has the nearest approach to common taste. The ranks are given of first judge, second judge and third judge. Now what we have to compute? We have to calculate three sets of coefficient of correlation between the ranking of first and the second judge, that is R1 and R2, second and the third judge, that is R2 and R3, first and the third judge, that is R1 and R3. So the ranks are already given, so we will write the ranks. Then what we will do? We will compute the differences. First we will compute the difference between the first and the second rank, that is D1 to R1 minus R2. R1 is 1 and R2 is 3. The difference between these two will be -2. 6 minus 5 will be 1. Similarly, we will compute the difference between these two ranks. Then we will proceed further. We will do the square of D12. Then the second case, we will compute difference between rank 2 and rank 3. We will find out the difference between R2 minus R3. So R2 is 3 and R3 is 6. The difference will be -3. So second is 5 and 4. The difference will be 1. Similarly, we will compute all the values, and after computing all the values, what we will do? We will do the square of all the values. So next we will compute the values for R1 and R3. The difference will be R1 minus R3, that is 1 minus 6, that is -5. 6 minus 4, that is 2. Similarly, we will compute the difference. Then we will do the square of D13. And what we will do? We will compute the summation of all the D square. Start. Now, the formula is RR or rho is equal to 1 minus 6 summation D square divided by N square minus 1. So first we will calculate R12. That is 1 minus 6. The D square D12 is 200. We will put the value. N is 10. N square will be 100 minus 1, and we will compute the value minus 0.212. Similarly, for rank coefficient, that is R23 will be 1 minus 6 D23. The summation value is 212. We will write the value over here. N is 10, N square is 100, and the value will come out to be 0.297. Similarly, for R13, 6 into D13, that is 60. The value will come out to be 0.636. So the conclusion will be, since there is a positive correlation between the judgment of first and third judge, therefore this pair of judge has the nearest approach to the common taste of beauty. Now, the second case, when the ranks are not given. So what we have to do here? We have to rank, and the rank may be assigned in ascending order or descending order. Generally, it is preferred to give rank in descending order. The highest value is given rank 1 and so on. So we will proceed with the numerical. So calculate rank difference coefficient of correlation from the following data. Value of x is given and value of y is given. So first we will write the value of x. Now what I have to do? I have to compute rank. So the highest value here is 95. So we will assign 95 1. Then the next value is 85. We will assign 2 to 85. Then the next value is 81. We will assign 115 will be assigned 6, 110 will be assigned 7 and 100 will be assigned 8. Now what we have to do? We have to compute the difference between these two ranks, that is Rx minus R1. That is 5 minus 5 0, 2 minus 4 is minus 2. Similarly we will compute the differences and then we will proceed with the d square. So the d square will be 0 square 0 minus 2 square 4, and similarly we will compute all the values and so we will find out the summation of d square. Now what we have to do? We have to put the values. RR is equal to 1 minus 6 summation d square and n square minus 1 is the formula used. Here 1 minus 6 summation d square is 6, n is 8, n square is 64 minus 1, 1 minus 0.071 and RR or rho will come out to be 0.929. Got it? Now we will proceed with the third and the final case.
Start.
Now case 3. When some values or ranks are equal, that is the case of tied rank, equal or repeated ranks. Here what we have to do, if 2 or more items have equal value, then the items are given the average of ranks. And the formula used here is R is equal to 1 minus 6 summation d square plus 1 upon 12 m cube minus n, and we will proceed similarly divided by n square minus 1. So where here n is equal to number of items whose ranks are common. This thing we have to take into consideration when we are doing the case of tied rank. Now the formula, now the illustration. Find the rank coefficient correlation from the following data. Marks in statistics is given and marks in maths is given. So for marks, for statistics I have taken x, and for marks, for maths I have taken y. The values are assigned. Now what I will do? I will assign the ranks. So the highest value here is 60. 60 will be given 1. The next value is 56. Now 56 is coming 2 times. So what I have to do? 2 and 3 divided by 2. The value will come out to be 2.5. So I will assign 56 2.5 value, and similarly next 56 will be assigned 2.5 value. Now next will be 2 values. First, second, third values are taken into consideration. Ranks is taken into consideration. Now the fourth value will be 54. Then the fifth value will be 45. Now we see 45 is coming again. How many times? It is coming 2 times. So what I will do? I will take the average of 5 and 6. That will come out to be 5.5. Similarly, I will compute rank for the tied values or repeated values. What I have to take? I have to compute the average values of these two ranks. Now if I take y series into consideration, the highest value here is 45. 45 is assigned 1 rank, then the 44 is assigned 2nd rank, 42 is assigned 3rd rank. Now 40 is assigned 4th rank, 36 is coming 3 times. So we have assigned values till 4. Now 5, 6, 7. 3 values. What I will do? I will find out 5, 6, 7 average. It will come out to be 6. So I will assign 6 to this 36. I will assign 6 to this 36, and I will assign 6 to this 36. So 5, 6, 7 values are exhausted. Now the next rank will be 8 given to 32, 9 given to 30, and 10 given to 20. So now we will proceed similarly like the other method. We will compute the difference between the rank and the square of the rank, and we will compute the summation of the rank. Now we will write the formula. So here we will have 3 m's. M is equal to 2 for the rank of 56, and we have computed mean of 2 and 3 values in the x series. M2 is also equal to 2 rank of 45, and it is the mean of 5 and 6 value. And M3 is taken into consideration from the y series, the rank of 36, and its mean was 5 plus 6 plus 7 divided by 3. Now the formula is 1 minus 6 n square, d square here is 36, 1 upon 12 compute the values and the value will come out to be 0.76. So we have completed the 3 cases of rank correlation. Thank you. We will proceed with the next lecture in the next class. Next topic in the next class. Thank you.